Welcome back at my channel. So in this video we are going to start to cover the in a Laplace transform that we have started. So let's proceed our discussion. Let's series expansion method. By using the series expansion method, we can find the Laplace transform of a given function that have not done previous solved by the previous method. So here some example when if it is a function, we can expand it c1 plus c1t plus c1 t square c2 t square plus c3 t cube dot cn minus 1 t n. So the Laplace transform of ft will be the Laplace transform of c0 plus c1 Laplace transform of t plus ct Laplace transform of t square dot Laplace and cn minus tn. This is our main concept. So find the Laplace transform. First question is given by find a Laplace transform. Laplace transform of the given function. So sin t sin root t. Okay. When we find it, it will give us, so Laplace transform of sin root t will give us what? Expand it. Expansion of will give us root 2 cube upon 3 factorial plus root 2 5 upon 5 factorial plus so on. So Laplace transform will be the individual of plus in 5 by 2. Okay, this is give us what is this is the fraction, that is nothing but 1 by 2 Laplace transform t 3 by 2 plus 1 5 factorial Laplace transform t 5 by 2. We know that gamma function when it, t to the power n is not integer, they will give us gamma 3 by 2 upon s 3 by 2 plus that give us 1 by 3 factorial gamma 5 by 2 plus s 5 by 2 plus 1 by 5 factorial gamma 7 by 2 upon s 7 by 2. Okay, plus so on. So after proceeding this, you can easily find it. You take a common s 3 by 2 give us half root pi. Okay, have you reading it? That give us gamma, the value of gamma 3 by 2 will give us half root pi by s 3 by 2 plus 3 factorial that gamma 3 5 by 2 give us 3 by 2 into 1 by 2 into root pi plus 1 by 5 factorial s 3 by 5 by 3 by 2 5 by 2 s 7 by 2 that give us 5 by 2 3 by 2 and 1 by 2 root pi plus so on. When we take in outside, let's 2s 3 by 2 root pi minus 3 factorial is nothing but 6 s pi by 3 3 into 4 3 into 2 cancel. Similarly 5 factorial is 1 2 0 0 into s 7 by 2 when that will be 5 into 3 that give us 4. Okay, plus so 5 into 3 15 into 1 to 0 4. Okay, so yeah, if we take any root pi by 2 s 3 by 2 common, that will remain 1 by 4 s plus when we take outside that give us 16 s square. Okay, okay, plus so on. That give us root pi 2s 3 by 2 1 minus 1 by 4s plus 6 4 s square plus so on. That give us root pi upon 2s 3 by 2 e. This is the exponential shell order. What is, we know that 1 equal to x minus x square plus one into plus minus x square 3 factorial square you can get it. Here that will give us 1 by 2 factorial minus 3 factorial minus 3 factorial that give us 1 by 4s. Okay, that is no problem. By using this you can find it. Find the Laplace transform of 10 root t. Okay, you can find it. What is the Laplace transform of 10 root t? Can you find it? Laplace transform, find the Laplace transform of root t. I am showing the method, you can easily find it. So we have done the series expansion method. So what is the series expansion method? What is the 10 root t? 10 root t is nothing but what? X minus root t minus root t cube plus 3 root t 5 plus 5 minus root t plus 7 by 7 plus 7. So root t. Okay, so Laplace transform of 10 root t will give us root t 1 by 3 Laplace transform root t cube 1 by 5 Laplace transform 1 by 5 plus so Laplace transform, that is gamma, he will give us 3 by 2 gamma 3 by 2 upon s 3 by 2 minus 1 by 3 by 2 that give us gamma 5 by 2 and s 5 by 2 plus 1 by 5 by 2 s gamma 7 by 2 upon s 7 by 2. You can find a below by using Laplace gamma function. Okay, so you can find a value of Laplace transform of each. That will give us what? 1 by 2 root pi upon s 3 by 2 minus 1 by 3 factorial s 5 by 2 that give us 3 by 2 1 by 2 into root pi plus 1 by 5 s 7 by 2 that give us 5 by 2 3 by 2 1 by 2 root pi. So you can find a value of Laplace transform. So we have done the series expansion. Now we have to move the further, find the Laplace transform of the we have understand how to find use the Laplace transform how to use the Laplace transform for a given question. So we have done the Laplace transform of, we have done the series expansion method. Now find the Laplace transform. Please write down the question. Find the Laplace transform of the function. First question is sin t sin cos 2t. Find the Laplace transform. What is this? We know that sin x plus cos y is nothing but 1 plus sin x plus y minus sin x minus y. Okay, so what will be this? 1 by 2 sin 1 plus 2 3t minus sin 2t. So what is the Laplace transform of 2 will be outside sine 3t minus Laplace transform sine here 2 1 minus 1 will be minus from 2 that give us plus okay plus t. So what is the Laplace transform that give us s square plus 3 square sin t. We know Laplace transform sin at is nothing but s by a by s, okay, a by s square plus s square. Laplace transform cos at is nothing but s by s square plus s square. So we use this 3 plus s square plus 1 plus 1, okay. What will we get if we 1 by 2 s square plus 3 square s square plus 1, so s 3s square plus 3 s square plus 9, so 4 1 by 2 4s square plus 12 upon s square plus 9 s square plus 1. So 2 will cancel, so that gives us 2s square plus 6 s square plus 9 s square plus 1. So that is our Laplace transform. You can find a Laplace transform cos cube t. You can find it cos cube t. Find a Laplace transform cos cube t. Now similarly we can find a Laplace transform we have done, okay. Let's go to the further. Please, if you have not subscribe my channel. Now we have to find a Laplace transform. You can find it. Find a Laplace transform, okay. Have you done? So that's for you. You can use the formula of cos t sin t. So now we are going to find a Laplace transform. Find a Laplace transform of t minus sin hyperbolic a t. Find a Laplace transform of this question too. How to find it? Laplace transform of t cube minus Laplace transform sin hyperbolic a t. Here 1 minute. Here we have a 3 is an integer, not any fraction, so that give us 3 factorial upon s 3 plus 1, okay. So here we have find the by using the formula when n is an integer, that give us comma n factorial upon sn plus 1. So sin hyperbolic at is nothing but what is the sin hyperbolic t? A upon s square minus s square. So 3 factorial gives 6 f4 upon a minus s square by s square. That is your our Laplace transform of sin t square. Now next question, find the Laplace transform of cos hyperbolic a square t, okay. Can you find it? We know that. Now here we have a function. We use the formula Laplace transform 1 plus cos 2a hyperbolic 2at upon 2 give us the Laplace transform 1 by 2 Laplace transform of 1 plus transform of cos hyperbolic 2at, okay. So that give us Laplace transform of 1 by s plus cos hyperbolic t is nothing but s by s square minus 4a. That is our Laplace transform. So s square minus 4s square plus s square by s into s square plus 4a 1 by 2. So that give us, so 2 will be cancelled, so s square minus 2i square upon s into s square minus 4a. So that is our Laplace transform. You can easily find it. So that's for the today video. Can you find a next question? Find a Laplace transform of sine 80 plus b. I am given here. Sine 80 is nothing but sine 80 cos b plus cos 80 plus sine b. So Laplace transform of sine 80 plus b will be sine Laplace transform of sine 80 plus cos b outside plus cos 80 plus sine b. So you can find the Laplace transform. So we have done the Laplace transform. The other concept we have left, we will move forward when we have to next video. So if you have not watched, subscribe and follow me. Thank you.